So good morning everybody, I am Jayashree from Department of Biomedical Engineering from SNS College of Technology. I am going to take the 8085 microprocessor. Let me see the introduction of the microprocessor. The 8085 is an 8-bit microprocessor that was introduced by Intel in 1976. It is a popular and widely used microprocessor in the field of computer architecture. The 8085 microprocessor is a part of 8085 family, which includes the variations of 8085A and AH and 8085H. Let me see the introduction of the 8085 microprocessor. The 8085 microprocessor is based on the von Neumann architecture, where data and instructions are stored in the same memory space. It features the simple and straightforward architecture, making it suitable for the wide range of applications. The 8085 microprocessor is known for the reliability and ease of programming and efficient execution of instructions. Let us see some key features of 8085 microprocessor. It is an 8-bit processor. It can accept, process and provides 8-bit data simultaneously. It provides 8-bit I/O address to access 248 256 I/O ports. It has 16 address lines, hence it can access 64 kilobytes of memory. It also has 16-bit stack pointer that stores the address of the top of the stack memory. It operates on 5-volt power supply, which is connected to the power supply VCC, and the ground is connected to VSS. In 8085, the lower 8-bit address bus and data bus are multiplexed to reduce the number of external pins. Since the buses are multiplexed, we need latch to separate the address and data bus. Next one, let us see the architecture of the 8085 microprocessor. This is what the architecture of the 8085. The major blocks includes accumulator, temporary register, flags, ALU, instruction register, instruction decoder, and serial I/O control, interrupt control, address lines, and data bus buffer, timing and control circuit. Let us see one by one in detail. First one, interrupt control. Interrupt control in INTR and INTA, where INTR is nothing but the low signal pin. It is going to give the request to the processor. For interrupt acknowledge, in the sense, it give as soon as it completes the interrupt programming, it give acknowledge to the processor. And RST 7.5, 6.5, 5.5 and trap, these are the interrupt pin which are going to give interrupts, which are going to give the interrupts by using the pins. Next one, serial I/O control. If you want to access the data serially, input data and serial output data, we need to use this serial I/O control. Next one, accumulator. So accumulator, it is used to perform arithmetic and logic operations, and almost all the results are stored in this accumulator. Next one is what, temporary registers and flag register and ALU. Flag register is nothing but store the status of the result of the arithmetic and logic operations. So for example, let us see registers in detail. So the registers, there are 8-bit registers. There are 8 8-bit registers: A, B, C, D, E, H, L, F. The 8-bit registers are accumulator, B register, D register, C register, E register, H and L register. And two 16-bit registers are PC, program counter, and stack pointer. Here always the address is unidirectional, whereas data bus is bidirectional, which is indicated by this arrows. And general purpose registers, temporary registers are W and Z. General purpose registers are B, C, D, E, H, L register pair, and temporary registers are W and Z. Special purpose registers are accumulator and flag registers and instruction registers. Next, 16-bit registers are program counter and stack pointer. So these are the basic operations which are already executing in 8085. When you want to when you want to run down program, first it fetches the data. and then it decode and execute. These are the main three functions which are going to perform in 8085 processor. Next one is what? Timing and control circuit. The timing and control performs the overall operations of the 8085 processor. It has a clock out, ready, read bar, write bar, ALE, status signal, IO or memory, and hold and reset. If the processor is ready, we can give, by using the ready signal, we can give the input to the processor. And if you want to read the data from the processor, we can use the read bar. If you want to write the data to the processor, we can use the signal write bar. And ALE is used to separate address and data bus. Status signals whether it is used in IO or memory. And next one is what? Hold and reset. Next one, clock and clock signal. So clock signal is nothing but we can give the certain clock frequency which is connected at this 2 points x1 and x2. With this pins are we already seen. If the read bar is low, this pin should be enabled. Next one is what? Interrupts. There are 5 types of interrupt signal: trap, RST 7.5, 6.5, 5.5, INTR. These all are input signals, whereas INTA is nothing but the output signal. It is acknowledge pin. So it is indicated by this outside arrow. So trap is a non-maskable interrupt which does not be disabled by any of the priority. It has a highest priority. And other 3 pins, RSS 1.5, 6.5, 5.5 is the second, third and fourth highest priority. And INTR is the lowest priority. It can be disabled by any other highest priority. So thank you all.